Okay guys, welcome to example 7. So for example 7, this is something we've already done before. This is factoring trinomials. And so when we have a trinomial like this, we have x squared plus 7x plus 12. We look at this 12 and we say, okay, 12, what are factors of 12 that add up to 7? So my factors of 12 are, of course, you can't see that, are of course 1 and 12, 2 and 6, or 3 and 4. So which one of these adds up to 7? 3 and 4 add up to 7. So I'm just gonna take x plus 3 and multiply it with x plus 4. And if I multiply this all out, I'll get x times x is x squared, x times 4 is 4x, x times 3 is 3x, so I add those together, get 7, and then 4 times 3 is 12. So that would be how I got that. But now I have this. And now instead of, if you look up here, we don't have any number here. So we know that it's a 1. Here we have a 6. So I have to do something a little bit different. So my first step is going to be, I'm going to take my 6 and multiply it with my 5. I'm going to take my a value, multiply it with my c value, and I'll get negative 30. So I say, okay, what are my factors of negative 30? Negative 30. So now I'm going to do the same thing as I did before. I'm going to say, okay, my factors of negative 30 are 1 and 30, 2 and 15, 3 and 10. Let's see, is that it? I think so. Do any of these subtract to make 7? Not this one. No, not this one. Oh, but this one does, right? Negative 3 plus 10 is 7. So I'm just going to take these and I'm gonna take these and I'm just gonna add them together. So I'm just gonna rewrite this expression here. So it's gonna be 6x squared minus 3x plus 10x minus 5. And if you look, this is the same thing as this expression, except I just broke this into two different pieces. And now that I have this, I'm gonna take this and I'm gonna look at this and I'm gonna say, okay, I'm gonna look at this part and then I'm gonna look at this part. So then, if you remember what we did in the last example, we were factoring out GCF, greatest common factor. So what's the greatest common factor between 6x squared and negative 3x? It's a 3x. And then I'm left with 2x minus 1. And then here, what's my greatest common factor between 10x and negative 5? Well, it's 5. So if I take that, I get 2x minus 1. Oh, and great, these are both times 2x minus 1, so I did something right. So then, if I was gonna, I'm just gonna do what I'm gonna do, and then I'll tell you why I'm gonna do it. So I'm gonna do 3x plus 5, 3x and 5, times 2x minus 1. So the reason I did that is because that's reversing the distribution that we could have done from here. So we'll take the 3x and multiply it to both places, and we would take the 5 and multiply it to both places. But instead, what I'm doing is I'm saying, oh, well, this 5 is multiplied to both places, and this 3x is multiplied by both places, so I can put them together. So now let's move on to example 9. So if we look at example 9, what we have is, we just have one of those ones we had in example 7 where we don't have an a value. So we'll just look, what are my factors of negative 3 that add up to negative 2? My factors of negative 3 are only 1, 1, and 3. So I'll do negative 3. So I'll have x plus 1 times x minus 3. Okay? Now this one down here looks so complicated. I don't know what to do. I have this 5a plus 1 squared minus 2 times 5a plus 1 minus 3. But what I do notice is that I have 5a plus 1 here, and it's squared, and I have 5a plus 1 here. So if I just say, well, we're just going to say we're going to do this. Let's call that y. Let's call that, or let's call it x. X. Let's call this x. So I have x squared minus 2x minus 3. That's the exact same problem as I had above. So now I'll have x plus 1 times x minus 3. Am I done? Not quite, because I know I didn't really have x. What I had was 5a plus 1. So I'll just replace it. I'll do 5a plus 1 times 5a plus 1 minus 3. Okay. And now, let's move on to example 10. So now for example 10, we're going to move back to the special formulas that we were working with before. So if we hang on a second, I'll pull those up again. So here are all my special formulas. I have difference of squares, which we've talked about. We have the sum of perfect squares and the difference of perfect squares, which we've also talked about. Now we have the difference of two cubes and then the sum of two cubes, which we haven't talked about yet, but we'll work with those in a little bit. So now we have 4x squared minus 25. So what we do is we look back at our special formulas. Which special formula does this look a lot like? It looks a lot like this one. It looks a lot like the a squared minus b squared. So we say, okay, well, what's the square root of this? That's 2x. And what's the square root of this? 5. So we'll do 2x minus 5 times 2x plus 5. And now, looking at example B, I have the same thing. Here's a square, I have x plus y squared, and then I have minus z squared. So the only reason I can do this is because it's minus, right? This one was minus, this one was minus. If it's plus, I can't do this. But it's minus, so I can. So I'm just going to do the same thing. So it's going to be x plus y minus the square root of z times x plus y plus the square root of z. Okay, so I have my a minus my b, a plus my b. Okay, and now let's look at 11. So now I have 11. I have 27x cubed minus 1, and then I have x to the 6 plus 8. So what I notice here is I have cubes, and here I have a minus sign. So let's look back at our guide and see which one we can use. So we have cubes and we have a minus sign. So we're going to use this difference of cubes formula, this a minus b times a squared plus ab plus b squared. Okay, and so the acronym that we're going to use is SOAP. And I'm going to write that over here. Where'd it go? So I'm going to use SOAP. S-O-A-P. Same, opposite, always positive. So, same, opposite, always positive. So then, I know that I have my a value, so I do the cube root. What's the cube root of 27? What times itself 3 times is 27? So that's 3. And what times itself 3 times is x cubed? X. So I have 3x, and then what times itself 3 times is 1? 1. So same, I have to use my negative sign. So now, if you look back at the formula, it was a squared. So my a is 3x. So 3x squared is 9x squared. And then opposite, so a plus sign. And then it's a times b, so it's 3x times 1. So that's just 3x. And then always positive, so plus. And then always positive, my a value is 1, and 1 squared is still 1. Okay? And now on to b. So I'm going to use the same formula, except now I have a plus sign. But I'm still going to use my SOAP, my same, opposite, always positive. So I have, okay, what times itself 3 times is x to the 6th? That'd be x squared. So I have x squared plus, because always same is a plus. What times itself 3 times is 8? That's 2. So I have x squared plus 2 times. Now I'm going to have my a value squared. So x squared squared is x to the 4th. And now same, opposite. So now I have a negative sign. opposite. So I'm going to take my 2x and or my 2 and multiply it with x squared because AB. So I have 2x squared. And now lastly, always positive. So plus, I have my b value, my 2, and I'm going to square it. So it's plus 4. Okay, and that's example 11 for you. And we're going to leave there for now, and I will pick up with the other examples in a little bit.